Bismillahirrahmanirrahim. We continue our Ionic equilibrium topic with subtopic acid dissociation constant and base dissociation constant. So what is acid dissociation constant, which is represented by capital K subscript A, Ka. We also call it Ka. It is a quantitative measure of acid strength for weak acid. If we write the dissociation reaction for acid, if we write for strong acid, this arrow is a full-headed arrow. Single arrow with full-headed, kepala dia dua-dua side. But if we write for weak acid, we write this equilibrium or reversible reaction arrow. So this is the general form for acid ionization. Ha react with water to give H plus A minus, or hydronium ion plus A minus. This is another example. HCl plus water become H3O plus Cl minus. Okay, so acid dissociation constant for this reaction is a sum of the product divided by the concentration of the reactant. So for this one, this is the equation. Remember, H plus is also equal to H3O plus. So it's up to you if you want to write H plus or H3O plus. Okay, but it is a sum of product divided by the ratio of product to the reactant. So that is Ka value. So what does Ka means? If Ka is large, means that that weak acid, even though it is a weak acid, but it is a relatively strong acid, stronger compared to another weak acid. If Ka is a small value, the acid is weak acid, slightly relatively weak compared to another weak acid. Lower the value for the constant, the more the equilibrium lies to the left. Means that lie to the left lies to the reactant side. Means that it does not dissociate. If let's say you put 1 mole, maybe 0.01 mole only dissociate, and the rest 0.99 still undissociate. This is very important for determination of pH for weak acid. Okay. Now we look at the base dissociation constant, which is represented by Kb, or we call it Kb. Kb is the quantitative measure of acid strength for weak base. So Kb is the ratio of product over reactant. By looking at this equation, acid-base equation, so we have base react with water. Water give one of the proton to the base, and base form OH. From that water we get OH minus. This is an example for ammonia. We have ammonia react with water to give ammonium ion plus OH minus ion. So the Kb for a reaction of ammonia is the product OH minus times with the ammonium ion divided by the concentration of ammonia. So remember, this type of kurungan is represent the concentration of the substance. Similar to the Ke, if the Kb is large, means that that weak base is comparatively or a relatively strong base in that group. Yeah? If the Kb is small, the base is a weak compared to another other weak base. Yeah? Lower the value for the constant, the more equilibrium lies to the left. Yeah? Means that it will not dissociate much. Yeah? Same like acid just now. If you have 1 mole, maybe just 0.001 mole will react to form BH and OH. The rest will still remain as B and water. If let's say we have 1 mole, so how much will left? 1 mole minus 0.001 just now. So maybe 999 left on the left side. Okay. So the relationship between pKa and pKb. Yeah. So let's see what is the relationship between pKa and pKb to the Ka and Kb. So pKa, remember P is negative log. Yeah? So pKa is negative log Ka. pKb is negative log Kb. The lower the value for pKa or pKb, the stronger the acid or base. Yeah? The higher the value of pKa and pKb, the weaker the acid and base. Yeah? Okay. This is good for you if you remember this concept. Yeah? The lower the pKa or pKb, the stronger the acid. So just remember one. Another is the will goes to the opposite. Yeah? Lower will become strong, higher will become weak. Yeah? So just remember one. This is an example of calculation of weak acid and weak base. Yeah? So let's see what is the question. Determine the pH of 1 molar solution of acetic acid given its Ka value equal to 1.8 times 10 to the power negative 5. So this is how you are going to solve this problem. Yeah? For me, it's good for you to create this table. Tak perlu complete table lah, tak perlu draw all the line. You just do this line, this line, this line, this line, and this line, and write the balance equation. Yeah, that's why it is very important for you to know this acid, how does it react with water. Okay, so this acid, remember, acid will donate this hydrogen. So you see this one, when it donates the hydrogen to water, it loses the hydrogen and become minus because hydrogen is a plus. Yeah? So of course the equation must be balanced. It will become CH3COO minus and water will become H3O plus. Yeah? So initially we have 1 molar. So initially we have 1 molar of the acetic acid. We don't have anything on the right because it does not dissociate yet. Yeah? The concentration of acetic acetate ion and hydronium ion is 0. When it change means it dissociate. Yeah? When it's change or when it dissociate, minus X, this on the right side, we write plus X and this also plus X. Yeah? And because we don't know what is X, yeah? We are going to determine the X value. You just write X first. Then at equilibrium, we have the initial concentration minus with X, yeah, because it react X much. Banyak mana dia reacts? X. So banyak mana dia hilang is also X. Yeah? So 1 molar minus X. On the right side, X and X. So berapa yang dia akan ada on the right side at equilibrium when the reaction complete is X and X. Yeah. So we write the Ka expression for this reaction. So the Ka expression for this reaction is the product, sum of the product divided by reactant. So we have CH3COO minus plus H plus or H3O plus divided by CH3COOH. So what is CH3COO minus and H plus? Is X and X. So X and X, X times X, we get X squared divided by 1 molar minus X. Yeah? So you just write 1 molar minus X. So since the Ka value is slightly small, yeah, we just assume 1 minus X is almost equal to 1, yeah, because if let's say X is 0.00001, so it will become 0.999 berapa 9 kan, which is almost equal kalau you bundarkan, ya, kalau you round up, dia still lagi 1, yeah? So you just write it like this to make our solving problem much easier. Jadi you solve this, you arrange back this equation, yeah? X is equal to X squared is equal to Ka, yeah? You arrange back this equation. Kita assume that this is 1. So kalau 1, kosong je lah kan, divide by 1, tak perlulah kan. So X squared that we get from here, yeah, X squared is equal to 1.8 times 10 power of negative 5, which is equal to the Ke. Jadi you can find the X, yeah. Square root of this value, you will get X. So that is X, or the H plus concentration. So once we get the H plus concentration, which is equal to 4.24 times 10 to the power negative 3, we can calculate the pH, because the pH is negative log H plus or H3O plus. Okay, so this is the way how to calculate the pH, or how to solve the problem like this. Okay, okay, remember this assumption. This assumption is only valid if the X divide by once we get the value of X, you divide back the X with the initial concentration, which is 1. If the value is less than 0.05, so the approximation is valid. Yeah? Okay. Kalau tak, you kena solve X guna square root equation. Yeah? So Ka or Kb must be less than 10 to the power of negative 4. Okay? So that is the calculation of pH for weak acid. Similar to the weak base. Yeah? So we will see how to solve a problem, how to calculate the pH for weak base. Okay, so by that we stop here first. Kita discuss lagi on the next video. Assalamualaikum.